A curve is described by the vector function r of t is cos ti plus sin tj for t between 0 and 2 pi. We want to find the gradient of the curve at a general point P. There's a couple of different ways we could do this. We have x is cos t, and that means dx dt will be negative sine x. We have y is equal to sine t, which tells us dy dt is equal to cos t. I just made a mistake here. Notice that's an x and it really should be a t. So that's all good. And then dy dx, which is what we're after, the gradient, would be dy dt multiplied by dt dx. So that's going to be cos t multiplied by 1 over negative sine t. So we can say that that is negative cos t over sine t. There's other ways of doing this. We could, for example, get the Cartesian path and then differentiate implicitly. We wouldn't get dy dx in terms of t, but we'd get an equivalent statement in terms of x and y. But let's just leave it with this. We want to find the value of t when the gradient equals 0. So this really should be values of t, because if we want it to be 0, then what we want is for cos t to be equal to 0. We need the numerator to be equal to 0 for the fraction to equal 0, and that would happen at pi by 2 and also at 3 pi by 2 in this range.